Hello and welcome back on another conversation on artificial intelligence. Today with me, we have a very, very interesting person. He's both a professor and an entrepreneur. So before we go into this, let me thank you if you're coming back to the channel. And if you're new, it is an honor and privilege to have you here today. So what we're going to talk today is a very, very, very interesting area of machine learning. And it's basically the interface between the hardware, so basically the electronics that is used for implementing machine learning, and the software. Why is this important? It's because the next generation of intelligent systems that will affect our life, from devices that stay in our cars to the mobile phone and the things that we can do with the mobile phone, to the voice device, to the smart house, they will require more intelligent devices. It's not going to be only a software play, but we will need more intelligent devices. So without further ado, let's go to our guest today. Eugenio is a full professor at Purdue University, and he's also the CEO and founder of Forward Next. Hello, Eugenio. How are you today?
Oh, thank you. It's a pleasure to be here, Paolo. Thank you so much for the time.
There are a few scientists in university that attempt to, create companies and kind of transform the R&D into a real product. But it also takes a lot of efforts and some type of, personality and type of interests. Can you tell us a little bit about, what motivates you and a little bit about your journey so far?
I studied computer engineering and electrical engineering for most of my life. When I was young, I was very interested in trying to understand how computer work. And this, I'm talking about when I was 10 or something in middle school. So that was my passion. And then during my school years, I got very interested also in computers that could replicate some of the functionality of our brain. So I was interested in computers that could do things as well as humans. And at the beginning, of course, computers can do a lot of calculation much better than us, right? But there were other things that they couldn't do, like drive your car or see if you were having a bad day or not. So I think, that was my passion, as my big interest was always trying to replicate some of this functionality in computers and devices. Yeah, that's what brought me here. And also, because this is a very much applied area. It's not just research, you have to do some research, but we already have a lot of the pieces. I always like to put them together into products that could help us to live a better life.
Imagine that you go back to the high school and you meet, the girlfriend that you had at that time, and imagine that you had to convince her to be your girlfriend today. What would you tell her about yourself? How would you convince her?
It's funny, because when I was at that age, it was always difficult to talk to other people sometimes. I don't know. I felt that way maybe. Today, I would just tell them that I am a geek maybe and that they have to accept the fact and, we can have fun watching movies and doing all sorts of things. But they also have to have fun with me, sometimes maybe playing video games or listening conversational computers or things like this, right? So it's a bit of a quid pro quo maybe.
It's what I call the nerd revenge. So basically, from 60 years old, 16 to 25, it's when you are a nerd. Basically, everybody looks down at you and you feel like insecure and so on. As life proceeds and you make a better career, then there is a second part of life where you kind of become more self-confident, and it's kind of the nerd revenge sets in.
It's true, definitely, yes.
I would like to introduce our audience to your research. You do a lot of interesting things and you have lots of interesting interests. So I would give, like an overview of what are the topics that you address in your lab as a scientist, especially why. What are your whys, your motivations for doing this?
For sure, again, my big interest is to try to have machine be able to do more things that would help us in everyday life. I'll give you a couple of examples because some people might not understand. They're fairly mundane tasks, but imagine, I spend a lot of time, for example, cooking and cleaning up the kitchen. It would be really awesome if, I could have a robot that would cook for me whenever I don't want to do it, maybe clean up the kitchen, arrange the dishes or things like this. These are fairly mundane things, but if you think about it, if we had an appliance like that, a lot of people would want to buy it.
If it works,
if it works,
reliably and dependably, and it doesn't cause me to, have to rework it then yes.
Yeah, and that's the problem, I think. Right now we're nowhere close to it because think about cooking, for example, and the simplest thing is you have to peel a potato or cut some vegetables, right? So a robot would have to, first of all, find the knife, find this object, figure out how to position their hands to pick them up, and then he has to figure out the best way to cut them into small pieces, and then he has to put them in another container. And they all look different, right? Like potato that I have today looks different from the potato tomorrow. And a lot of people, I think, don't understand how hard this is for computers because they say, well, we do this every day. What's the big deal? But it's very hard because if you try to program computer to do all these steps, there's like so many possibilities that you cannot really program them. So instead of programming them, we have to have them learn on their own, maybe, or learn by seeing examples. And that's what I'm really focused on. I'm trying to have computers or create algorithms and hardware that is able to learn from, for example, a video. Sometimes we want to fix a small thing that broke in the house, or we look for a recipe. Where do we go? We often go to YouTube or some video online, right? And then we see somebody gives us instruction how to do it. It's mostly they show you how to do it, right? So I like computers to be able to do the same. I can show them how to do something, and then they'll be able to do with all different scenarios, right? Just like we do. That's basically our goal.
Is there, let's say, one particular element of your research that you're particularly proud?
Our group, at least, and myself, we've been working for more than 15 years on hardware for machine learning and deep learning. This is basically some special processor, like an Intel processor, but it's specialized to run a neural network, which are some model of maybe our brain. And coupled with deep learning algorithms, they can basically try to replicate what our brain does to solve certain tasks. Let's say, for example, look and analyze your pictures so that I can sort them automatically. I think many of us have thousands and thousands of images on your hard drive, but sometimes you would want to just find all the pictures with Paolo when we were at the beach and something like this. So these things were not possible like 10 years ago, but they're possible now because of these algorithms. And looking forward, basically, our goal is to create better hardware and software so that we can do more and more things, take away this mundane task and repetitive task that we don't want to do, really.
So for those who haven't been in machine learning or in artificial intelligence before, machine learning is a subsector of artificial intelligence, and it's basically the subsector that deals with algorithms that make program able to learn. So basically, a program that learns on a one task, and then it's able to accommodate various variations of that task and still being able to perform. That's what machine learning here is. Deep learning is a particular subsector of machine learning whereby the algorithms that are used are mimicking the human brain to a certain extent. It's not complete, it's to a certain extent. And it's called deep because basically the number of neural layers has expanded in recent years, and this has made this type of machine learning a little bit more powerful, has extended the capabilities of what can be done, but it's not still like a human brain. Probably the one thing that is referred to as artificial intelligence right now in the media at this point in time, but it's not really human intelligence. Because these new algorithms that are more powerful but also more complex have come to fruition, now there are new challenges being created. So for example, these algorithms not necessarily can always work in all circumstances because they need to work on sometimes computers that are powerful enough. Can you talk us about 2 or 3 use cases where basically the hardware today or the hardware that is used in that context is not sufficient?
There's a few examples of things that are happening today. For example, today we start having devices at home that can listen to some voice commands. So maybe some of us have an Alexa at home or Google Home or devices like this, where you can ask a question, you get an answer, you can, interact with them somehow. But a lot of what happens is that devices digitize your voice and send it to some powerful computer in the cloud, right? Some remote server. And doing so, they might violate some of your privacy because you don't want your speech, for example, your conversation to leave your house. So something that we can do today with better hardware is to have all the processing that happens in the cloud happen in this device that you have at home. And very limited choice a very limited set of operations then can be accomplished in the cloud.
Basically, the so-called artificial intelligence moving from the companies that provide the service, basically the company's headquarters or it moves from there to your house. That's an important use case. But are there that you see other use cases besides the privacy where it's really the performance on the device that is crucial?
Part of it is also the response speed, right? So if they have to go all the way to the server and come back, obviously it takes some time, and it doesn't feel like a natural conversation like the one we're having right now, right? So there's also that problem. But in general, it's also the ability to process your voice and understand your setting a little bit more. So this device right now doesn't know too much about you or your house. It's difficult for it to understand, when you're summoning it or when you need it, and if you need some more advanced things, right? It would be more interesting if you don't have to call it, hey, Alexa, blah, 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 right? But it would just understand that you're talking to it sometimes because of the context and everything else. So I think there's some advances in the algorithm and also advances in the processing speed and power allows it to do more if it's closer to you than a remote server, for example.
So personalization is basically, privacy is one of the benefits to move the intelligence from the cloud to a specialized hardware close to where the user is. Personalization seems to be another important aspect because now the device can really learn. The learning mechanism is inside the device, so the device can learn about your personal circumstances. So are there things that we cannot do today, for example, on a mobile phone, that would be enabled by your type of technology?
Yes, absolutely. You can think, for example, about autonomous cars. Is one example where you need a lot of processing and it cannot be connected to the cloud, and it has to be very fast in responding. And I know that there are already some products available. They're trying to do some of this processing, but it's never quite enough. The product that we're building at Forward Next, for example, can accelerate this algorithm and basically make your car perform better, learn as you go, and also be able to sense the environment better than even us human can do. Imagine having a set of eyes all around our head, for example. That's what you could do. Other examples are in smart cameras. A lot of security cameras up to today, they're not very smart. They send all the data to the cloud for processing or to another server, right? But if we were able to put our hardware in such devices, then you can do local processing. They can respond much quicker. And again, they don't violate privacy. So it's both the privacy and the time, the response time that are important. But they'll also be able to do more interesting things that they cannot do today. For example, recognize what your actions or recognize what are typical things that happen around the camera. So find the novelty detection or find issues that are not common, right? And this requires more powerful algorithms and also requires more powerful hardware, basically.
A lot of people use mobile phone. Just to connect our audience with the mobile phone, can you talk about like a specific case where a mobile phone capabilities would be expanded because we changed the chip inside the mobile phone?
Mobile phone is also one of the targets that we've always talked about. So if we could put more intelligence into it, it would basically become a more powerful assistant to you. I don't know, some of you might have seen the movie Her, where there's a phone that is a very powerful assistant. It looks and sounds like a human. It knows a lot about you and so forth, right? So the idea is that if we could have better algorithm and more processing power, the phone could listen into the conversation and provide you information without you having to ask, just like another person in a conversation. But it could also remind you of things. The phone also has a camera, so it could analyze the scene where you are and give you pointers or remind you of things. Hey, you're missing the next meeting if you don't move fast, right? Or, it could give you information about the persons you talk to if it's combined, for example, with augmented reality glasses, so some way of giving you information, without you having to look at the screen necessarily. So in general, it will become a better assistant and somehow become also more human, more interesting to talk to and share information with.
Do you see specific improvements around, taking pictures, retrieving pictures, or, like getting guidance? Because the use of the mobile phone, the use of pictures in the mobile phone, pictures and video is pretty pervasive. So far, it's more one where people take pictures and post them on Facebook, or they save them to share with their friends and family. But do you see new use case being enabled by hardware technologies on the mobile phone?
Some applications are actually already starting to cell phones today. The Pixel phone from Google or the new Apple phone have some neural processor capabilities, again, some kind of artificial intelligence processor that can enhance images. So they can make them look a little bit better, more sharper, or can combine. But I think the next step would be also to be able to sort and categorize your pictures directly. So that, for example, it's very common that you're looking for a picture with a friend or a year ago, and you just cannot find it because there's like millions of images on your phone, right? So if instead you could just say, hey, I want that picture, and automatically would retrieve them for you, maybe even on the device, right? So that would be very useful, I think. And there's a lot of applications like this. Phone knows a little bit more about you and what the conversation around you and the environment around you, maybe even visually. Then it will be able to guide you during the day a little bit more. And of course, today we have phones with GPS, so they can do some of it. And there's also a question of invading your privacy. But if you can make a good software, I think that it doesn't become annoying. I think there's a lot that we can gain.
It looks like the future in the next couple of years is going to be very interesting. Now, I would like to, move to Forward Next. This is the company that you're working on, and look a little bit more closely to the technology. Before we do that, I think it'd be interesting to understand from your perspective the difference between, say, a processor and a GPU, why the GPU is used with certain type of applications, particularly deep learning, and trying to understand where your new device, which is basically a processor, fits in between GPU and CPUs and why. So can we position it, in between what's already today out there?
Yeah, today, if you want to run this algorithm of artificial intelligence or machine learning, most likely we'll use some kind of a graphic processor, this GPU that were designed for doing gaming, but they're also very good at calculating, crunching a lot of numbers. So they become very popular in running some of these algorithms. The issue with these devices is because they're designed for some other application, they're not very efficient in running deep learning operations, mostly in terms of power. So they have great capabilities, but they consume too much power. So it's infeasible, for example, to put them on a small camera, on a drone, or any mobile robots, for example. Just because they wouldn't be able to last very long. They would drain the battery very quickly. And CPUs, the standard CPUs from Intel are even worse in that sense because they don't have compute power enough, and they also take a lot of energy.
What about the size? Usually when I see a GPU card, it comes big like that and has onboard cooling.
You're right. One of the byproducts of consuming too much power, you need a lot of cooling, so it makes them even bigger. What we're doing at Forward Next, we're trying to, the device that we're producing next year will have the same computational power, one of these big GPU that you mentioned, but it will consume half a watt. So then it won't need as big of a fan or a big of a package to run. You'll be able to place it in any small device, like a camera, even in your front door. And we talked about a lot of applications. There's also, you could have these devices in a lot of appliances in your home as well, so that they could help you pointers or understand your needs every day. So yeah, that for Next, basically, that we are trying to minimize the power of the device and also provide as much performance as possible so that the future algorithms that are going to be even more computationally intensive, they'll be able to run efficiently.
I think that's extremely interesting from my viewpoint because not only the possibility to go on a mobile phone and other type of devices, including the voice devices, the home devices, the cameras, and probably the drones and other things that are out there in the make. But it also seems that expands the capability, like it goes beyond what's possible in terms of even individual performance of these algorithms. If you have a phone, a mobile phone, okay, equipped with your chip, suppose that the battery is the same as today, what do you think is a potential pay toll in terms of battery life of equipping?
That's a great question. Today, if I left my phone on to listen to my conversation, probably drain the battery in less than an hour, maybe half an hour or so. With our system, you'll be able to run it all day long, at least 10 times more, so that you'll be able to just charge it at night like you regularly do.
So to the extent that you can tell, where is the secret sauce? Like, where do these numbers come from?
The numbers come from our experience in the field, so both experience in the algorithm, but also experience in making efficient hardware. So we design hardware that is very specific to the application. It doesn't do other things. And that way we can save power. At the same time, also, we removed a lot of unnecessary logic that standard processors have because they have to be able to run all these different programs, right? Ours is just dedicated to this, so we were able to really optimize it. And also because it's actually our 5th generation of processor that we developed over the years. So a lot of this experience, especially in the software, allows us to say, well, we know what kind of workload, meaning what kind of application we're going to be able to run, and we know which one are more or less frequent, right? So we can just focus on the more frequent one and put all our best implementation techniques there.
Is there any optimization on the material side, on the physical science side, or it's like materials or new materials, or it's just the design that has changed, has been optimized?
The component of this architecture are fairly standard. There's always a memory, a processor, and we always design them in standard silicon process. There's not a lot of difference between the one you see today out there. Maybe the only difference is that, at least for the future, is we're trying to make this device more closer to memory and more efficient in communicating with memory. I would say that's also like one of the secret sauce we're working on.
If you're gonna look at processes where you're monitoring my voice 24 hours a day, or you're monitoring my environment 24 hours a day, there is not only an issue of processing power, but there is also an issue of where you're gonna put this data. And portion of them needs to be saved, a portion of them maybe you can discard, but the data element is there. So how is that taken care of?
A lot of these devices are connected to a regular processor that has his own memory system, hard drive and computer memory and everything. And that they can interface to this. But I think also this question is a good question because it brings up something about the algorithm that I think is important to know. So a lot of the advances that we have today in this field, neural network, understanding speech and everything, it's because we have a lot of data set and that have been labeled by humans. Up to a certain point, we can scale. We can we can hire more humans labeling data and to train these devices. But at a certain point, we will not have such abilities, right? For example, we can't possibly label every action that a person can do in a video. There's just too many possibilities, right? And it's also very hard to label video. So we need to also devise a new learning algorithm that can learn by themselves without a lot of supervision. This is one also the goal of our work that we're focusing on. And you see some of this algorithm in the reinforcement learning field, autonomous driving, where you're trying to apply them to robots to get, do something and get a reward. And learning like that is the way we learn, and it's more efficient because you don't need the supervision of somebody like a teacher all the time available for you, right? Where you just need it sometimes. So that's like an important step that we have to make as a community to provide more interesting capabilities.
That's a very large topic altogether. I think I'd be interested on the hardware/firmware side. When are these new capabilities going to be, out there in the market? And after that, what will happen even next? Like, what is your vision for the next 3-4 years?
Our interest is to grow the ability of this processor to execute a larger and larger application, right? So there are some things that we can do today that we're designing an optimized microchip that will be released in about a year. We're not the only one. There's also other product coming out from several large companies. I would think next year you'll see some of them coming up. That will basically become a little bit like the Intel chip, the PC was at the beginning. So I think it will give a lot of people, developers, the ability to develop new applications in this area. So I think in the next 1 or 2 years, you'll see the same thing that you saw when the PC came out. A lot of programmers started programming and creating all sorts of applications that we use. On the other side, we try to make this hardware 10 times more powerful by coupling it to efficiently with memory, maybe using new fabrication technologies. And that will allow us to run a much larger algorithm that we cannot run today. They'll be able to listen to all the area, the conversation around you, not just yourself, but maybe multiple people speaking. They'll be able to view and understand the video content, not just like we do today to know what's in a video, but they'll be able to understand actions and also the sentiment. They'll be able to have an opinion about a movie just like we do when we see one. And so they'll be able to also help human users more because they'll understand, that you're having a bad day, for example, or they'll understand that you are more impatient, and so they'll be able to adapt to you more.
That's definitely something that is not only interesting, but I would say something that we look forward to because it's basically the next expansion of capabilities of the devices that are around us. So we'll become more dependent than we already are not. I remember I was a very late adopter of smartphone. And then it was like an acceleration. So I went from being a later adopter to be like early adopter. So I started to, look into all the apps and so on because I think there was a begin phase of the mobile phone revolution where it was not fully clear what was the benefit of all these apps. They were not like tangible in your life. And I was very, I would say, hesitant to adopt because I thought this is another thing that's going to take a lot of my time and not giving me benefits. But then there has been a transition. I became kind of an early adopter in a second phase. Eugenio, this has been like a very, very interesting conversation. As we move towards the end, one thing it'd be interesting to know is, we talked about, how this field of machine learning, particularly deep learning, will be more empowered by this new type of hardware and how devices around us, mobile phones, smart cameras, smart voice devices, so on, will be more intelligent in the near future because of the devices that you are building. But is there out there another area of, artificial intelligence or technology that piques your interest a lot, and why is that?
Yeah, a little bit we touched upon it. It's again the idea of learning in general. The name machine learning means that machine have to learn, right? I feel like they're still programmed, right? So up to today, we have this paradigm where we sit down in front of a computer and we program it. So we basically tell him instruction by instruction what to do. And if we just give the wrong instruction, he will do the wrong thing. That's not great help. It's help, but it's not great help. What we would like is that somebody that we can treat more like another person. We can give them rough instruction and they can fill the blanks the way that they would help us. So, for us doing programming, for example, it means to do less programming, right? Maybe write a simple set of instructions that are more high level, and then let the computer understand where to go. But it also means that these algorithms need to really do more learning, right? So they have to be able to take a large data that was not labeled or was not annotated by humans and be able to somehow process it to some internal knowledge. Then it will be later useful to understand our needs.
Are you actually working today? Some of the behavioral scientists out there in university tell us, is there an overlap between the two disciplines?
There is definitely an overlap. A lot of what we do is always inspired by neuroscience and understanding the brain and neural system. And definitely it's something that we've always been keeping an eye and been working on for many years. I think it's very important for us not only to understand the hardware, but also very understand the software and what we want to do, the capability very well, because we're building in a new revolution in computing in a way where we make this machine more easily to program and help us in everyday tasks without having to tell them, line by line. You know how frustrating that is when you have to tell somebody, exactly what to do. But then we are doing that with computers.
Yeah. I think this has been great. This conversation, once again, was a conversation on how devices around us is going to be empowered by new hardware inside them. And this will generate more capabilities in these devices, more intelligent cameras, more intelligent cars, more intelligent voice devices, more intelligent smartphones. This conversation has been very interesting, Eugenio. I thank you so much for being here. As far as our viewers are concerned, thank you for your time. If you have questions, please write them down. If you have suggestions for other topics that you would like to learn about, we're happy to receive those suggestions. Also, if you want to see more of this content, do not forget to subscribe to our channel. So thank you so much for your time, and thank you again, Eugenio.
Thank you for having me.